Good morning, and welcome to the second of two videos on Chapter 1, an introduction to statistics. Okay, in this video, we're going to start with a discussion of what we call the order of operations. All right, whoops, sorry, one more. You may remember this from your math classes in high school or even earlier as the order of operations, or PEMDAS. Okay. Some of you probably learned the little acronym, please excuse my dear Aunt Sally, all right, where the P refers to parentheses, E refers to exponents, M is multiplication, D is division, A is addition, and S is subtraction. Okay. And so what this suggests is that parentheses and square root signs, in other words, the P and the E, always come first. Okay. And so these symbols that you find in your mathematical equations always go first. So anything that you find inside a set of parentheses or under a square root sign indicate that something that you have to do first. All right. So unless otherwise indicated, you always either square or take the square root, unless there's a set of parentheses first. Then you multiply or divide, and finally you add or subtract. All right. And anytime you're doing an arithmetic operation, you always go in that order. All right. Whatever's in the parentheses, you do first, then any squares or square roots, then multiplication or division, and then addition or subtraction. Now, if you have both multiplication and division, you simply go from left to right. If you have addition and subtraction, you go from left to right. Okay, so that's the order of operations in math. And again, there should be no surprises here. This is stuff that you should already have seen in high school or earlier. Now, oftentimes when you do a calculation, especially if you do a calculation using a magic number box, you may end up with a number that's really long. All right, most calculators will give you 6 or 8 digits in an answer, and so oftentimes writing down all 6 or 8 of those digits can be cumbersome. It can be a messy kind of deal, and so therefore, oftentimes you'll be asked or expected to round your answers. There are rules that go with rounding. And so the first rule is that you carry out your calculations so that the final answer after you round has 2 more decimal places than the original scores. All right. And so if every score that you're dealing with goes to the ones place, you'd be expected to round your number to the hundredths place, the fraction. All right. So 2 decimal places. All right. It's important to remember that you should never round until you get to the very final answer. All right, do not use rounded numbers in your calculations. So never round off at what we call intermediate steps in a formula. All right, always wait until you get to the final answer before you round. The general rules for rounding a number. You look at the next place, the place after the one you want to round to, and if that digit is a 5 or a greater, you round the digit you want up. And of course, if it's 4 or less, you round down, okay, or just keep the number, all right? And so, for example, if you had 46.7 and you wanted to round that to the ones place, that would give you a rounded number of 47. If you had 32.3 and you wanted to round that to the ones place, it would simply be a 32. Okay, because in this case, the 7 is greater than 5. And in this case, the 3 is less than 5. all right? And this is true no matter how many decimal places you have, right? If you want to round to the hundredths place and you have 52.361, and you wanted to round it to the hundredths place, well, the 1 is obviously less than 5, and so this would round to 52.36, okay? And so rounding is something that you probably already have a pretty good idea about. Now, transformations. These are mathematical procedures for systematically converting a set of scores into a different set of scores. So let's say your teacher gives you, quizzes that are worth 50 points and tests that are worth 100 points, all right? And so let's say you scored a 37 out of 50 on your first quiz, all right? And you scored an 87 out of 100 on your first test, all right? Well, you'd want to know exactly what those numbers mean. And so we could transform these into a proportion. Well, 37 out of 50 is 0.74, okay? And 87 out of 100 is 0.87, okay? And so what that means is that percentage-wise, you scored a 74% on your first quiz, and you scored an 87% on your first test, all right? Now, that doesn't tell you what your average is in the course, but it gives you an idea of where you might stand, all right? You got a C on your first quiz, and you got a B plus on your first test, all right? That probably puts your average at a C plus or a B minus, all right? But that's not the point here. Each of these two steps that I represented between here and here is a transformation, and converting the proportion into a percentage is also a transformation. Okay, and so when we transform numbers, especially in statistics, generally speaking, we're trying to get them to all kind of fit into the same mold. All right, that's what transformations are really all about, so that the numbers are comparable. Now, as I indicated in the previous slide, proportions are an excellent example of a transformation, and one that we frequently use in statistics. A proportion is a decimal number that falls between 0 and 1, all right? And it essentially indicates a fraction of the total. All right, that's what when you first learned decimals in elementary school, you learned that a proportion is 0.74 or 0.87. All right, and as I indicated in the previous slide, in order to transform a number to a proportion, you simply divide the number by the total. So if you had my mouse is very sensitive. So if you had 67 out of 77, all right, let's say your quiz was worth 77 points and you scored a 67. Well, how would you figure out what that was? All right, well, you can easily simply take your magic number box, all right, and do 67 divided by 77, and that gives you 0.87. And notice I'm giving this 2 decimals, whereas these guys had 0 decimals. So 2 decimals more than what we did, or what we had. And so that's a proportion. We scored an 0.87 out of 1, if you will. All right. Now that, of course, translates into a percentage of 87%. Okay. And so all you got to do is divide the number by the total. All right. Let's say you had 53 out of 75. All right, well, in that case, all right, 53 divided by 75 is going to give you 0.706666666667, all right, which rounds appropriately to 0.71, all right, which is, of course, a percentage of 71%, okay? But the 0.87 and the 0.71 are proportions, all right? And they allow you to compare two scores that may be out of a different total, like 77 and 75, all right? We can compare these two scores. The scores are the 67 and the 53. Now, by putting them into a proportion, they're comparable. We can literally see which one is better than the other. Now, a percent is simply a proportion multiplied by a 100, okay? And so to transform a percent back into a proportion, you simply divide it by 100. So let's say we had 45 out of 50, okay? This, if I calculate the proportion, is 0.90. If I take that and I multiply it by 100 to give me a percentage, that gives me a 90%. Okay? All right, so that's what a percentage is. And I showed you a couple of percentages in the previous slide as well. Now, let's say I had a proportion of 0.85. All right, well, that's going to be 85%. Okay, a proportion of 0.21 is 21%. Okay, and of course, all I need to do in order to go backwards from a percent back into a proportion is to divide by 100 as opposed to multiplying by 100. All right, and so these terms, percentages and proportions, are interchangeable. All right, simply by multiplying by 100 or dividing by 100. And again, proportions and percentages are excellent ways to make scores comparable. All right, especially if the raw scores are out of a different number. All right, if you have 67 out of 80 in one group and you have 52 out of 70 in another group, can you compare those numbers? Well, you can if you convert them to proportions or percents. Okay. Now, another way that we can analyze statistics is by using graphs, right? And it's important to know a couple of things about graphs, right? First, when you graph a set of data, the scores along the horizontal axis is are referred to as the X scores, okay? Generally speaking, the left-hand side of the X-axis is the lowest score, and the far right is the highest scores. And so reading from left to right, you go from lowest to highest. On the other hand, the vertical lines are the Y-scores. And again, we start with the lowest score on the bottom and the highest score on the top. Now, a couple other things that you should know about graphs are that the X scores are generally what we call the independent variables. They are the numbers that we are given or that we work with. Okay. The Y scores are the results, the measurements that we make on each of the numbers in the X axis. All right, and so they are the dependent variables. In other words, Y depends on X. All right, so we pick an X and we figure out what its Y is. All right, so the X scores are the independent variables. The Y scores are dependent on the X variables, if that makes any sense at all. And I think hopefully it should. Now, how do we look at a set of data regarding a graph, or how do we look at a graph regarding a set of data? Well, in this case, let's move on. And so here we've got a plot of height and weight. And what we're going to say here is that height is going to be our independent variable, and our weight is going to depend on our height. All right, and so we graph the height on the x-axis and the weight in pounds on the x-axis. Now, on the y-axis, I'm sorry. There's a couple of things I don't like about this graph. First, this and this, all right? A true science graph, and I know this isn't science class, but I'm a scientist, and therefore I want to point this out. A true graph should never have a break in either of the axes, okay? Because what that does is it diminishes the visible differences in scores. All right, and so the x-axis should start at 0 and go all the way up to the highest point. The y-axis should start at 0 and go all the way up to the highest point. Now, that may leave you with a lot of empty space on your graph, but that's okay. In science, that is definitely the way to go. People who publish graphs in newspapers and magazines and things like that may use this little trick in order to save space on the page. All right, but in reality, a true set of data should never deal with broken axes. Now, in this case, you can see the various folks listed here. You got 6 different data points. Their heights are listed in inches. Their weights are listed in pounds. And we've got a relationship that is reasonably linear. All right, it's tough to draw a straight line with this mouse, but reasonably. And what I've drawn here on this graph is what we call a best fit line. Now, in reality, you should do this with a ruler. Of course, I'm doing this freehand with a mouse, but this is the best fit line. And best fit lines are important in statistics because they help us to see the relationship that might exist between, for example, height and weight in this particular case. All right, more on graphing later on. All right. Now, we'll conclude this video with 2 examples of the order of operations and some of the mathematical operations that you're going to be expected to do. All right, and so in number 1, we have the equation x over 2 plus y as our function. Crying out loud. And so x over 2 plus y equals, all right? Now, if x equals 10 and y equals 9, then this becomes 10 over 2 plus 9 equals, 10 over 2 is 5. 5 plus 9 equals, and of course, 5 plus 9 equals 14. All right, and so that's how we would get through this particular example. In the second one, it just is the square root of y, and of course, if y equals 9, then the term or the function becomes the square root of 9, and the square root of 9 is 3. All right, and we're going to skip the third example here because for a variety of reasons, but don't even worry about it. Okay, so that brings us to the end of the second of 2 videos on Chapter 1, an introduction to statistics. Your assignment for next class is going to be to do the application questions on page 11 in your textbook. Now, in doing homework, what I would like you to do is first only do the odd numbered problems. And so the application questions start with number 11 and they end with number 24. So I want you to do questions 11 through 24, but only the odd numbers. Please do them on a separate sheet of paper. It can be a piece of computer paper or loose leaf or whatever it is. And I would like you to submit them to me in an email. All right. Take a picture of them using your phone, convert it to a PDF or whatever it is, and then email it to me directly at my email address, grapp@siena.edu. All right. Please make sure that they're submitted before your next class. So before 10 o'clock on Thursday in this particular case. All right. Now, just so that you know, at the end of your textbook are the answers for all of these problems, all right, the odd numbers, all right? And so don't just go to use that as a resource to make sure that you've done it correctly. But don't just go to the answer key and copy the answers. I want to see your work and how you actually got these answers, at least for when you can. All right. Because I want to be able to help you to figure out what you are doing wrong, if anything, so that when we take our first quiz, you'll know what you're doing. All right. So that is, my friends, the end of the second of 2 videos on chapter 1, and I hope you learned something.